Jai Guru student and good morning. Today we will start with shapes of d orbital. So d orbital shapes is your double dumbbell. So if you want to draw a d orbital, for example, now in d orbital how many boxes, student? 1, 2, 3, 5 boxes in d subshell. So we have 5 orbitals, 1, 2, 3, 4, 5. 5 orbitals are actually dxy, dzx, dyz. These are in between axis, and dx square minus y square, dz square are on the axis. On axis, and this is the in between axis. These are in between axis. Now if I want dxy, dxy, this is in between dxy axis. This is one lobe, 4 lobes you have to do, 2 lobes, 3 lobes, 4 lobes. This is dxy, dyz, and again like that. The shapes are available in the book also, student. You have to go through that. Now one of the important shapes that I want to draw about the dxy, this is dz square. The dz square looks like that. dz square is the only d orbital with 2 lobes. So it is a ring there in between that one. So in this one the angular node becomes 0, but for the rest of the one, for this one angular node become 2. If I consider that the xy axis, then yz and zx axis are the angular node. Here angular node is 0 because of this one, because this ring touches the other two axes, other two planes in this one. So this part is, remember, the only d orbital with 2 lobes. This is your d z square. So this one is important. So after that, student, we are taking the difference between the orbit and orbital. So orbit, though we have learned these things are orbit. This orbit consists of 2 electrons. This orbit consists of 8 electrons. First orbit contains 2 electrons, means 2 into 1 square. Second orbit 8 electrons, means 2 into 2 square. 2 electron, 8 electron. So that rule is governed by 2n square. Now in this one, in orbital, what happens? These are the orbitals: s orbital, p orbital, d orbital. Now we know if any orbital is there, means orbital, these boxes are orbital. In one box we have maximum how many electron? 2 electron. Like that in this one 2n square electron, but here it is 2 electron. Now all the orbits are directionless, no direction. Here this one either x-axis, for example px, py, pz, they are having some direction. Only s orbital having no direction. So you remember these things. This is an 2-dimensional, this is 3-dimensional. These are the difference between orbit and orbital. So 3 difference will do, 3 difference you have to learn. Next one, we have to learn about degenerate orbitals. The orbitals having same energy are called degenerate orbital. If the orbitals having same energy, These are called degenerate orbital. So for hydrogen, the degenerate orbital depends on principal quantum number. If principal quantum number same, then they are degenerate. So for hydrogen, we are going to draw a diagram. This is energy. If this is your 1s, then this is 2s and 2p. Now we have same principal quantum number, means their energy is same. We have 3s, 3p, 3d. Same quantum number, energy is same. We have 4s, 4p, 4d, 4f. Now same for multi-electron system. This is for multi-electron system. Things differ. This is your 1s, this is 2s, this is 2p, this is 3s, this is 3p, this is 4s, this is 3d. So for multi-electron system, these things depends on n plus l value. Whatever will be the n plus l value, whichever having the lower value, this is lower energy, higher and higher. So what you have to learn, the state of minimum energy of electron in an atom is your ground state, and any other state of higher energy is called your excited state. Then we have another effect. This is your skinning effect or shielding effect of inner shell electrons. Now in this one, first of all, if I take the example of hydrogen having only one electron, so this electron, wherever it is moving, so there will be, for hydrogen there will be no skinning effect. Skinning effect means what? If something is screens, the one electron is screened by the other electron. So hydrogen having one electron, there will be no skinning effect. It is like that when the sunlight is falling on you, when the clouds come in between you and sun, then the effect of sunlight falls on you will be going to be reduced. Like that, if the layers after layers of clouds comes, then what will happen? That there is still more skinning effect, and there will be decrease of the effect of sunlight on it. So like that, if I consider this next member of hydrogen, after that we have considered the helium. Helium having two electron system. These are in the first shell. Now these are the first electron of helium. Then if I have the other electrons of helium like that, now these electrons, sometimes it depends. This is your one electron, this blue electron, and this is red electron. Red electrons comes between nucleus and the blue electron, so there is some skinning effect is there. Skinning effect here is not equal to 0. Now what I want to understood about the skinning effect is that if for multi-electron system, if there is no inner electron, consider there is no inner electron, then this is the charge of the nucleus is Z, charge of the electron is E, then there is a force of attraction is Z into E. Now if I have inner electrons, then this Z effect of Z is reduced. If I consider Z effective, that become Z effective into E, and this, it may be 20% loss, maybe 30% loss, whatever may be the loss, this is called skinning effect sigma. So this is what is called skinning effect. This is your sigma. Sigma is the value of skinning effect. So whatever value for the sigma comes, this is your skinning effect. So actually what we have learned, that this reduction of the effect of nuclear charge, whatever may be the value of reduction of the effect of nuclear charge on the electron due to the presence of inner electron, this is called skinning effect, or another name, this one is shielding effect. So up to this student today, you do the other parts are there, above principle, all these things will take in the next class.